Hi, future GISPs. I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to spend years reading textbooks, getting degrees, paying for prep courses, and searching the internet for information like I did. In this video, I'm going to teach you everything I learned about spatial data standards, including ISO, FGDC, and OGC. Spatial data standards, including ISO, FGDC, and OGC, is the 8th section under the Geospatial Data Fundamentals category of the GISCI Geospatial Core Technical Exam list of knowledge categories. Let's get started with Section 208, Spatial Data Standards, including ISO, FGDC, and OGC. Interoperability Standards. Interoperability standards are how spatial data are served between networks of hardware and software systems. Interoperability standards facilitate sharing and access to GIS data. Analysis standards. Analysis standards ensure that the correct analysis are used and that the analysis produces the best information possible. Professional and certification standards. Professional and certification standards establish the education, knowledge, or experience of the GIS analyst, thereby improving the likelihood that the technology will be used appropriately. The Geospatial Competency Model. The Geospatial Competency Model identifies a set of core and sector industry geospatial abilities. The Geospatial Competency Model identifies 40 critical work functions GIS professionals are commonly expected to master and use in their careers, and the background knowledge on which these critical work functions are based. The Geospatial Competency Model was developed by the Employment and Training Administration, or ETA, and the Geotech Center, and industry experts. Competency categories of the Geospatial Competency Model include personal effectiveness competencies, academic competencies, workplace competencies, industry-wide technical competencies, industry sector technical competencies, management competencies, and occupation-specific requirements. Geospatial abilities listed in the Geospatial Competency Model include positioning and data acquisition, analysis and modeling, software application and development, teamwork, creative thinking, planning and organizing, problem solving and decision making, working with tools and technology, checking, examining, and recording, business fundamentals, reading, writing, mathematics, geography, science and engineering, communication, listening and speaking, critical and analytical thinking, basic computer skills, intrapersonal skills, integrity, professionalism, initiative, dependability and reliability, and lifelong learning. The Geographic Information Science and Technology Body of Knowledge, or GIS&T. The Geographic Information Science and Technology Body of Knowledge is a comprehensive outline of the concepts and skills unique to the geospatial realm. It was first produced by the University Consortium for Geographic Information Science. The Geographic Information Science and Technology Body of Knowledge was published by the Association of American Geographers in 2006. It is the basis for the Geospatial Competency Model. Spatial Data Standards. Spatial data standards are methods for structuring, describing, and delivering spatially referenced data. There are 4 categories of spatial data standards: media standards, format standards, accuracy standards, and documentation standards. Media standards are for the physical form in which data are transferred. Format standards are for the file components and structures. Accuracy standards are for the quality of the positional and attribute accuracy. Documentation standards are for how spatial data are described. Data accuracy. An accurate representation represents the true shape, location, and description of a phenomena in a GIS. Accuracy may be reported as a percentage of data that is accurate or as an average error. The Federal Geographic Data Committee, or FGDC. The Federal Geographic Data Committee is an organization of federal geospatial professionals chaired by the U.S. Department of the Interior. The FGDC leads the development, implementation, and review of policies, practices, and standards relating to geospatial data in the United States. The FGDC provides oversight and direction for geospatial decisions across the federal government. FGDC standards include addressing, metadata, content, data quality, soil codes, and wetland classifications. The FGDC oversees the National Spatial Data Infrastructure, or NSDI. The National Standard for Spatial Data Accuracy, or NSSDA, was created by the FGDC and is being replaced by the ISO standards. The CSDGM, or Content Standard for Digital Geographic Metadata, was created by the FGDC and is being replaced by ISO standards. The National Spatial Data Infrastructure, or NSDI. The National Spatial Data Infrastructure's purpose is to build data infrastructure for improved public and private sector applications of geospatial data and decision-making. The National Spatial Data Infrastructure provides tools to access and share spatial data. The National Spatial Data Infrastructure is administered by the Federal Geographic Data Committee. The Content Standard for Digital Geospatial Metadata, or CSDGM. The Content Standard for Digital Geospatial Metadata was developed by the FGDC. The Content Standard for Digital Geospatial Metadata requires agencies to document all new geospatial data it collects or produces using the standard and make the standardized documentation electronically accessible to the clearinghouse network. Content Standard for Digital Geospatial Metadata standards usually align with ISO standards. According to the CSDGM, metadata should include title, abstract, date, geographic extent, projection info, attribute definitions and domain values, identification information, data quality information, spatial data organization information, spatial reference information, entity and attribute information, distribution information, and metadata reference information. The National Standard for Spatial Data Accuracy, or NSSDA. The National Standard for Spatial Data Accuracy is defined by the Federal Geographic Data Committee. The National Standard for Spatial Data Accuracy specifies the number and distribution of sample points when performing an accuracy assessment and prescribes the statistical methods used to summarize and report positional error. The Content Standard for Spatial Data Accuracy states that an accuracy assessment should use 20 to 30 evenly distributed test points. It also states that each quadrant of the test layer should contain at least 20% of the test points. Sources of truth for an accuracy assessment can include GNSS, field surveys, or digital orthophotographs. The National Standard for Spatial Data Accuracy has standards for assessing point accuracy. It does not have standards for assessing the accuracy of linear or area features. There are 5 steps in applying the NSSDA. The 5 steps are: identify test points, identify true values, collect positional measurements, calculate the positional error and summarize it in a standard accuracy statistic, and lastly, record the accuracy statistic in a standardized form. The Federal Bureau of the Budget and the National Map Accuracy Standards. The Federal Bureau of the Budget publishes the National Map Accuracy Standards. The national map accuracy standards are larger than 1 to 20,000 scale maps must have 90% of the points be within 1/30th of an inch of the true value. Smaller than 1 to 20,000 scale maps must have 90% of the points within 1/50th of an inch of the true value. Elevation data must have 90% of the points be within 1/2 of a contour interval of the true value. An accuracy assessment must use at least 20 sample points. The Open Geospatial Consortium, or OGC. The Open Geospatial Consortium is an international organization of companies, government agencies, and universities that develops, approves, and maintains standards for sharing geographic data and maps over the web. The Open Geospatial Consortium's mission is to improve access to geospatial information and make location information fair. FAIR stands for findable, accessible, interoperable, and reusable. The OGC is a neutral forum where government, industry, nonprofits, and academia can work together to solve global challenges. OGC standards are available free of cost. OGC file-based standards include Keyhole Markup Language, or KML, Keyhole Markup Language Zipped, or KMZ, Geographic Markup Language, or GML, the GeoPackage, the GeoTIFF, and the laser, or LAS file. OGC and ISO simple features. Simple features standards are a set of standards that specify common storage and access models of geographic features used by geographic datasets and geographic information systems. These standards are documented in ISO 19125. OGC Web-Based Standards. OGC Web-Based Standards allow access to spatial data over the Internet as if it were stored on a local hard disk. This technology allows data to be mapped to the local computer as if it were stored locally. OGC Web-Based Standards include the Web Feature Service, the Web Map Service, the Web Coverage Service, the Web Map Tile Service, and the Web Processing Service. The Web Feature Service. A Web Feature Service returns discrete features. It provides an interface allowing requests for geographical features across the web using platform-independent calls. A Web Feature Service provides interfaces for manipulating operations including creating features, deleting features, updating features, retrieval, and querying features based on spatial or non-spatial constraints. A web map service. A web map service returns static maps. It is a standard protocol for serving georeferenced map images over the internet. A web map service provides two request types. A web map service has GET capabilities and GET commands. GET capabilities returns information about image format, available layers, coordinate reference system, and bounding box. GET map returns a map image. A web coverage service. A web coverage service returns multidimensional coverages in raster format that represent space-time varying phenomena. A web coverage service shares raster datasets on the web in a format that can be used as input for analysis and modeling. A web map tile service. A web map tile service is a standard protocol for serving cached map or image services over the internet. A web map tile service has GET capabilities and GET tile commands. GET capabilities requests metadata about the service. GET tile requests individual tile resources. A web processing service. A web processing service is an interface standard that provides rules for standardizing inputs and outputs for invoking geospatial processing services as a web service. A web processing service is an interface that facilitates the publishing of geospatial processes and the client's discovery of and binding to those processes. A web processing service has GET capabilities, describe process, and execute commands. GET capabilities returns metadata. Describe process returns a description of the process. Execute returns the outputs of a process. The International Standards Organization, or ISO. The International Standards Organization maintains international standards for GIS methods, tools, and services for data management through the ISO Technical Committee 211, or ISO/TC 211. The ISO charges fees for these standards. ISO standards are often required by public and defense sector entities. ISO 19115. ISO 19115 is a content standard that defines what should exist in metadata. ISO 19115 was created by Technical Subcommittee 211 to harmonize the content standard for digital geographic metadata with other standards. ISO 19115 is endorsed by the Federal Geographic Data Committee. ISO 19139. ISO 19139 contains XML schema implementation of the ISO metadata standards. It is endorsed by the FGDC. ISO 19125. ISO 19125 contains simple feature standards. Mandatory fields for ISO datasets include title, date, geographic location, language, topic category, abstract, and metadata. The American National Standards Institute, or ANSI. The American National Standards Institute is the U.S. member agency to the International Standards Organization, or ISO. The American National Standards Institute made the Spatial Data Transfer Standard, or SDTS, which is being replaced with the geographic markup language created by the OGC. The Spatial Data Transfer Standard, or SDTS. The Spatial Data Transfer Standard was created by the American National Standards Institute. The Spatial Data Transfer Standard is a method for archiving and transferring spatial data. It specifies exchange constructs such as format, structure, and content for vector and raster data. The Spatial Data Transfer Standard is being replaced by geographic markup language, which satisfies the Spatial Data Transfer Standard. The Federal Geographic Data Committee has proposed to withdraw the Spatial Data Transfer Standard. Spatial Data Transfer Standard Accuracy. The Spatial Data Transfer Standard states that raster data must be 95% accurate. It states that an accuracy assessment must use at least 20 checkpoints. So, only one of the 20 test points can fail accuracy standards. The Spatial Data Transfer Standard states that an accuracy test must be performed against an independent source of higher accuracy. The SDTS suggests computing the root mean square error. Infrastructure for Spatial Information in Europe, or INSPIRE, INSPIRE. The Infrastructure for Spatial Information in Europe is the organization that oversees spatial data standards in Europe. The American Society for Photogrammetry and Remote Sensing, or ASPRS. The American Society for Photogrammetry and Remote Sensing has nicknamed itself the Imaging and Geospatial Information Society. It has standards for geospatial data accuracy. In summary, many organizations have developed standards for spatial data accuracy. Currently, the Federal Geographic Data Committee has authority over spatial data standards in the United States. The International Standards Organization has authority over spatial data standards internationally. The Open Geospatial Consortium has done much of the work to create and implement data standards. Now you know everything that I learned about spatial data standards, including ISO, FGDC, and OGC, to easily pass the exam. Don't forget to thumbs up and subscribe to my channel so that I can keep helping people pass the GISP exam and achieve the rewarding careers in GIS that they deserve. You can also find everything I learned to pass the GISP exam in my book, The Ultimate GISP Exam Study Guide, available on Amazon. My study guide is an easily understandable, comprehensive, graphical, all-in-one resource for passing the exam. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam